Alright, hi there. This tutorial is for my students on how to create an object with OnShape and then cut it out on the laser cutter. And so the little tutorial we're going to be designing today is to make something to go on this OneBot by Patent Robotics that will allow students to be able to read and recognize this infrared soccer ball as it rolls around. And I made a little prototype here. The idea is we have this infrared line following kind of sensor that we're going to change and make into, normally they're here at the bottom, they use these to follow lines. And I'm going to make a little mount, show students how to make a little mount that goes on the side, like so. Okay. And so they can mount, 1, 2, or 3 here. For example, if you wanted to be a goalie, the goalie can move back and forth and follow the ball as the ball moves around. And so all of my students, I gave them this little guy, okay, this little radius cut mount for the OneBot. Okay, so it can go on here anywhere around, and we've got this is a through hole and that's a tapped hole, so we can mount that. And then this thing here will accept the plate that we're about to make. So we're going to make this piece here that will accept, like I said, this sensor plus another one, and it could mount onto the robot like that. Right? So before I even got started, this is a new laser cutter for me, and so I needed to figure out, what size holes would be good here. Notice there's no nut on the back. I'm using a 440 screw, and I've tapped these holes into the board. But because the laser cuts some of the wood away, I didn't know what size hole. So before I even began that project, I made this little jig. And so these holes are in millimeters, 10, 8, 7, 6. And then I know that I'm going to use a whole bunch of hole sizes here between 2 and 3 millimeters. So I figured out that the 2.7 laser cut hole on our Epilogue laser will make a through hole, and then the 2.1 cut would make a hole that's nice for tapping. And tapping just means you kind of cut threads into the piece of wood, and I use this tap, a 440 tap, and we just put that into the laser cut holes, and we just crank it like this, and that cuts the threads into the wood. All right, so all of that was pre-done, and so I know what size holes I need for my tapped holes. If you prefer, I'll show you how to use through holes, and then you can put a nut on the back of this instead of tapping if you don't have a tap. All right. So that kind of sets up the problem. Oh, and some other tools I used: a caliper, just a plain old, ruler, inch ruler, metric ruler, even. And so that's kind of the setup for what we're going to do. And then let me just show you what. This is essentially the plate we're going to make, right? And it seems pretty simple, and it is pretty simple. But all new CAD software, if you're not familiar with it, can be a little daunting. So I'm going to walk you through some good steps. And at the end, what I'll do is I'll show you how to take that plate here that we just made and made it with a whole bunch of other assemblies that I made in the past. For example, here's that made for the OneBot. And then I made little sensors here. We can explode it and take a look. I made little line following sensors that we would know that they fit. I'm using little spacers, so I made one of those, and we can see, what the tolerances are before we even go and cut it. So that's tight, but it does work, and lo and behold, it's exactly what the laser cutter gave us. All right, so that is the intro. I'm going to show you how to make this part and how to be able to edit and change around this part. So get ready for that lesson. Okay, so how are we going to make this plate? We go to OnShape and click Create, Document, and then we're going to name the document whatever we want. How about Plate and Holes or something like that? Or IR soccer plate, or whatever it is you're making. Okay, this is just an example. Okay, So first thing I like to do is we see the different faces here. I like to hide the front face and hide the right face. Because we're doing laser cutting, everything's in really one dimension, so we're going to go and use a top view. Okay. I should have mentioned in the startup that before I even start making, I do a lot of measuring. And so I have a plan on paper of what I want to do. So I have all my measurements really on paper. So I'm not going to be guessing here. I'm going to build with some pre-thought. All right. So what I want to do is I want to make a plate, and you have to go to Sketch. Okay, and you can name this sketch if you want to. You can name it Plate View or something like that. And you also have to tell it which one of these, which surface you're going to be creating the sketch on. So I click the sketch plane and I choose the top. Okay, so there it is, and I didn't have to name it, but I have to choose the top plane. Okay, or I have to choose a plane at least. Now we're prepared to add drawings onto our sketch. So I'm going to grab a rectangle, and I could make this be any size I want. Okay, so I'm just going to grab it and draw it. And then I know that I want it to be, let's say 6 inches across. So I just type 6 and I hit enter, and then it chooses automatically the next box. And I think I'm going to make that 2 inches, and we can change these later on. Okay, and you'll see how we're going to do that in a second. So that's that. I should mention that we are in inches here, and you can see this by clicking on the hamburger, going to workspace units. And when you're using OnShape and an epilogue laser cutter, it's really important you use inches. The rest of the world uses millimeters, I understand, but because we're going to be using Adobe Illustrator to do this, we need to work in inches, which is disappointing to me. Nevertheless, there it is. Okay, and now we need to make the 2 little tabs that are going to go on the bottom of the plate. Okay, and these can't be willy-nilly. We have to know what the sizes are because they need to mate with the other piece. So I need to make sure I'm back in the plane, or the plate rather, that top plane drawing. And I'm going to choose another corner rectangle, and I'm just going to draw down here, and again it highlights the first dimension, which is 0.75, hit enter, highlights the next dimension, which I know needs to be 0.4. If your little mount on your robot, if my students have a mount that's only 1 layer thick, you can make this second dimension be 0.2. You don't have to make it be double ply. But if you do have 2 sandwiched together, then you can make it 0.4. Okay. Next, I'm going to make exactly the same box, and watch how I'm going to do this. I'm going to grab this corner, and now if I move across, you'll see that they'll line up. Okay, so that's going to be helpful. And I'm going to come over here and click on this, and see the little dots, they line up like that. And so now all I have to do is type in 0.75, and the 0.4 is already done. Okay. All right. So the distance between them, is an odd distance, but it needs to be very precise. So here's what I'm going to do there. I'm going to choose this dimension tool. I'm going to click on this face, or this side, and I'm going to click on this side, and that's going to give me a horizontal arrow. And I know that the dimension is, and for the students who are making something like this, forgive this odd dimension, but it's 0.578667. Okay, and I know I don't need that much precision, but there it is. I have it, so why not use it? And then when I click enter, watch what happens to the 2 tabs. They're going to move a little bit closer together. Okay, so now they're the right size and they are the right distance apart. Okay. What we're going to need to do now is, if I unclick the dimension tool, you can see that I can grab this and I can kind of move it around, but it doesn't snap to anything, and I can't really put it right in the very center. I can eyeball it. I can probably get it close enough, but let's make it be perfect. All right, so here's how to do that. Number 1 is I'm going to grab this little point, and I am going to put it in the center of my bottom edge here. And you can see as I move toward the center, beep, that little icon right here below will change from a little T to a little line with a dot. That tells me I'm at the midpoint. So I press the dot, and I know now that that point is at the midpoint of that line segment. So what I want to do is I want to put this midpoint right here attached to there. Okay, so I'm going to draw a line, but I'm going to make it a construction line. So I click line, I click construction, and now whenever I draw my line between here and here, it's going to give me a dotted line, which will not be cut. I can then grab my point again, and I can choose the midpoint of that guy. So now I have 2 points that need to be coincident. They need to line up. So I'm going to press the coincident tool. I'm going to click on that point. I'm going to click on this point and watch what happens. Beep. They're going to move together. All right, so now they are one big piece. These constraints take a little bit of getting used to. Okay, so here this side here is constrained to be 6 inches, and this is constrained to be 2. We constrained this tab to meet in the middle, and all of this is really handy eventually, and I'll show you what I mean in a minute. But using constraints like this and knowing what you're going to do ahead of time is really important for this kind of design work. All right. What I need to do next is I'm going to need to cut out these little lines here. I'm going to use the scissor tool to trim. I want that little segment gone, and I need to do it again because there were 2 squares. Okay, so now that's one piece of wood. Do the same here. Do it twice. If we want to, we can grab this and kind of move it down so it gets it out of our way. And we're looking pretty good. We need to now make the mounting holes. And the mounting holes need to be, they need to be very precisely placed. As you can see here, maybe the mounting hole is near the edge because the Molex wire, the 3-conductor cable, has got to come in. They're very low tolerances. Has got to come on the other side of this, and there has to be enough wood to bite into the screw. So we're really cutting it really close. So I've measured that. Okay, and if any students are using this this line following sensor again from Patton Robotics, you would need to use these dimensions as well. Okay, so it turns out that we need to mount the hole 0.175 inches from the top. So we need 3 holes 0.175 inches from the top. So let me show you how to do that. Again, a line, again the constructor. I'm just going to come anywhere here and I'm just going to draw my line. And notice I need it to be parallel, perpendicular to the side. So there it is. You can see there's a little perpendicular symbol there. Boop, now I'm done. Okay, it's asking me to draw some more lines. I'm just going to press escape to get rid of that guy. Now what I want to do is I want to put this 0.175 inches away. I click the dimension tool, click that line, and now I can set this to be, 0.175. It moves the line. See how close it is. Okay, really close, which is fine. I need to put 3 little holes here, so I'm going to grab my point tool again. And there are probably 1,000 ways to make this happen. So I'll put one in the center. Okay, I'm going to put one 1/2 inch away from the edge. Whatever edge it is, I want it to be 1/2 inch away. So I'm going to grab another point, and I'm going to click it there, and I'm going to click one over here. Now, how do I make them 1/2 inch? Well, again, we grab the dimension tool, we click an edge, we click that point right there. Boop. Okay, and then we can just type in 0.5 and do the same. You see how it moved over, and we can do the same over here. Okay. Well, it's already chosen, so I can click on the point, click on the edge, and make that be 0.5. And again, boop, the little dot goes away. So now I know I have a perfectly placed and constrained points where I can put my circles. I'm going to grab my circle. This is going to be the holes for my tap screw. I'm going to click on the point, right? Okay, and I know, well, let's see here. If you want a tapped hole, okay, then with the epilogue laser cutter for a 440 screw, and you want this hole to be a tapped hole, then what you would do is you would type 2.1, and then it's important here to change it to millimeters, 2.1 millimeters. If you want it to be a through hole and you want to use a nut on the other side to hold the screw in place, then you want to use a 2.8. And again, you need to type in millimeters. But because I want it to be tapped and I don't want to worry about a screw and I have a tap, I'm going to do 2.1 millimeters. Okay, tiny hole there. And notice it's far enough away from the edge that I don't have to worry about it. I have plenty of space. I have plenty of space there. Okay. And now I'm thinking, I think I might have changed that distance. We'll see. I might have to come back and edit this. All right, so again, 2.1 millimeters for the tapped hole, and one more over here. I'm just using my mouse wheel to zoom in and out. If you don't use a mouse whenever you do CAD work, I think you're crazy. I prefer a mouse. You can just do so much more with the mouse wheel and the mouse buttons than you can with the trackpad. All right, so I'm going to pause here just to make sure that I haven't screwed up and made these dimensions here, this 0.175 dimension. I just want to make sure that's right before I move on. So hang on one second. Yep, I sure did make a mistake. So I am opening my file that I created earlier. I'm going to double click on the sketch here, and you can see here that line is really 0.15, and I changed that for various reasons because it just didn't fit, really. That's why I changed it. So let's go back to my current drawing. Okay, and watch how easy this is going to be. So I'm just going to double click on the plate. Again, I like to do it from the top down. And so where did it go? Over here. So now all we have to do is double click here. Okay, I'm going to type in 0.15 instead of 0.175, 0.15. Hit enter and watch what happens to my little dotted line, my little circles. They all move. Okay, and if you didn't notice it, let's try that again. So let's say I want it to be 0.85. That moved a lot, and they all move because they're all constrained, right? So again, these constraints allow you to make some quick and easy changes. The next thing we want to do is turn this into a 3D piece. Okay, so I can rotate around a little bit or click on the little view here and choose isometric. Okay, and we're going to choose this plate. I make the plate here be yellow, and then choose extrude. Okay, and then it thinks I want to move it up 1 inch, but I only want it to be 0.2 inches because that's the thickness of my plywood. Press the check mark, and now we are good. If we are done and would like to send this to the laser cutter, all you have to do is click on the part, right click on the face you want to export it as a DXF, call it something like IR soccer plate, something like that. It's downloading, and then what I can do is there it is in my downloads folder. I can move this to a more permanent folder so I can then use Adobe Illustrator to cut it. So that's where we are right now. So up above here is a link to a video on how to go from here to Adobe Illustrator to the epilogue. And there's also, if you want to keep doing this, you can, I'm going to make a video right now and post this in the link, and there'll be a video on how to make an assembly and how to further edit this. Okay, so you can either cut it or you can edit it. All right, thanks so much.